Interested in the force you are. Sortiori you have.
Okay, physicists. So let's get into forces. So we'll start off with, well, we'll go with Newton first. He's the man, the dude, possibly the greatest scientist ever. I would always struggle between him and Charles Darwin as to who are the greatest British scientists ever, but he's definitely, he's the man. Uh, we know him for, well, basically he invented all of our classical laws of motion, which still are the ones we use when we talk about everyday objects. Gravity, he described gravity in a way that hadn't been done before. He invented calculus, basically to work out how the moon rotates around the earth and the gravitational pull between those. He invented the knurling on coins. So you pick up a coin, you've got the little ridges around the outside. He invented that because, he works for the mint. And basically, he invented the scientific report that you deal with in class. Before him, everything was done as letters between scientists. He didn't invent the scientific method, but he formalised the way we talk about it. The apple is obviously there because there's the story, which is not true, that an apple fell on his head, and that's how he discovered gravity. But let's give the man the credit he deserves. He was, it was much more of a deliberate affair than that. And yeah, cranky dude, bit of a tool. Maybe the greatest scientist ever, but not a very nice guy. Anyway, back to forces, which is basically he discovered the mathematical relationship between forces and the other factors which we'll get into. So a force, what is it? A force is anything that can cause either a push, pull, or a twist. So if you can basically cause a change in an object in either, and add this, so if it causes a change in the object's motion, so you can push it, you can pull it, or you can change its shape by twisting it, or change its direction that it's moving. Okay, so it has a symbol. Force has a symbol, which means you've got another formula coming up, and that is F, and the unit that we measure is Newton. Now this has a lowercase n because it's not his name, that's his name. It's the name of a unit. The symbol is a capital N. You need to work those out, and that's going to be confusing. So what is a Newton? 1 Newton is the force, or the push or pull or twist required to accelerate a 1 kilogram mass, this is ignoring friction, by 1 meter per second squared. So 1 Newton equals 1 kilogram meters per second squared. Alright, so now we're going to talk about the relationship between force, mass, and acceleration. And when we say relationship, if you see this word, basically we're looking for a mathematical formula between 2 or 3. So in this case it's F equals ma. Force equals mass times acceleration. Now force, we're talking about the force acting on an object, newtons. The mass, we're talking about the mass of the object that the force is acting on, so the object being pushed, pulled, or twisted. So if we have a little Yoda here, and I give him a push, the force we're measuring is the push that I'm giving him. The mass we're measuring is the mass of Yoda, and the acceleration is his change in speed, basically. So if he's starting at 0 to whatever that would be, that's our acceleration. So acceleration is the change in motion of the object, not the thing doing the pushing. So if a 70 kilogram man is pulled by gravity downwards, whether he's fallen off a bridge, jumped off a building, or he's just standing there, gravity is still pulling you down all the time. So a 70 kilogram man is being pulled by gravity downwards at an acceleration of 9.8 meters per second squared. What's the force? So F equals ma, 70 kilograms, that's the man or the object. 9.8 meters per second squared That's the acceleration downwards. And the force is 686 newtons. This applies when we talk about your weight, by the way. Your weight is a force, it's not mass. So weight should be, by all rights, measured in newtons or pounds, not kilograms. Pound is a force again. Alright. Top work, physicists.
And now, my young Padawan, may the force be with you.